All right, so here are the notes over targets 6 and 7 for our polynomials unit. Um, targets 6 and 7 really kind of brings in things that we've already looked at before, just factoring skills that we already should have that we learned in the quadratics unit from last semester. So the first two problems here, A and B, are just kind of a review. They're kind of just a warm-up to get us ready for targets 6 and 7. So let's look at those. It's asking us to factor and solve the following quadratic functions. And if you notice in A, our A value is 1. You can just stick a 1 out front there, which means we can go ahead and skip to that kind of shortcut way of factoring when our A value is 1. What you're still going to have to do, though, is figure out which two numbers multiply to get negative 12, but then add to get 4. And what I like to do is just kind of write the factors of 12 off to the side here. We have 12 and 1, 6 and 2, 3 and 4. Well, 6 and 2 have a difference of 4, so it'll probably be 6 and 2. Let's see if we can make that happen. I'll do a positive 6 and a negative 2. 6 minus 2 will give me 4, and then 6 times the negative 2 will give me negative 12. So what I'm going to do is basically skip to this part here where I have my two sets of parentheses, and then I'll solve from there. X plus 6, x minus 2. That's just normal factoring when a value is 1. So let's see. I'm going to solve from here. Set x plus 6 equal to 0, and then set x minus 2 equal to 0. Over here I have to subtract my 6. I get x equals negative 6. And then here I have to add my 2. And I get x equals 2. Alright, and then for this one, a little bit different. I do have to factor out a GCF here, which I would have done in A, but there wasn't one. So always factor out a GCF. That should be your first step. So my greatest common factor here is 2. I wish I could factor out a 4, but I can't. 4 doesn't go into 30. So what I'm left with when I divide all three of these by 2 is I get 2x squared plus 15x plus 7 equals 0. So now I'm going to kind of follow the same pattern as I did with A. I still have to multiply two numbers together to get my A times my C, which in this case is 14. And then what plus what is going to get me 15. So kind of like A, but in this case my A value is not 1, so I have to take an extra step here. So factors of 14 that add up to be 15. Well, we have 7 and 2 and 14 and 1. It's going to be 14 and 1. All right, so essentially here, all I'm doing is breaking up this b term into 14x plus 1x. Still have my 2 out front. Still have my 2x squared. I just have plus 14x plus 1x instead of my plus 15x. All right, so now my next step is to look at the first two terms separately and then look at the second two terms, factoring out GCFs from both those groups. I can factor out a 2x from those two. I'm left with x plus 7, and then I can factor a 1 out of the last two to be x plus 7 left over in my parentheses here. And notice I'm doing parenthesis bracket because I don't like doing double parentheses. Well, x plus 7 and x plus 7 are the same thing, so I know I did that correctly. So I can go ahead and write this finally with my 2 out front still as 2x plus 1 times x plus 7. These two came together here, and then this came together with that. And then very last step would be just to solve. So I set 2x plus 1 equal to 0. And I subtract over my negative 1, I'm sorry, subtract over my 1, I get negative 1. And then x equals negative 1/2. That's my answer there. And then when I set x plus 7 equal to 0, I just subtract over my 7 and I get x equals negative 7 as my answer. So those are my two answers there. So that shouldn't have been new. That should have all been things that we already know how to do with the factoring when A is 1 and A is not 1. So we're going to go ahead and use that information and use that knowledge to move on to targets 6 and 7. So target 6, I can factor and solve a cubic by grouping. So it says factoring by grouping is a method we have been using from the first semester, which I just used in the warm-up. On the second one, it says this time our expression will be a cubic or degree 3 polynomial, so cubic or degree 3. The first step is to group the first two terms together and the last two terms. The second step, from those groups, factor out the greatest common factor, or GCF. In some cases, it may just be 1. If the first number in the parentheses is negative, be sure to also factor out a negative. Step 3 is if factor by grouping is not possible, the binomials left in the parentheses should be this. If it is possible, the binomials left in the parentheses should be the same, which we know. That's where I did the little green check marks. And if this is not the case, the cubic is prime or not factorable. And then the fourth step is to just solve, set them equal to 0 and solve for x. So let's look at A. This is already in a form that I can just factor by grouping. So looking at my first two terms and then looking at my second two terms separately. From the first two terms, I can factor out not only an 8, but also an x squared. So be sure to take out the largest thing you can. In this case, I can take out an 8 and an x squared. See what I'm left with when I divide that by 8x squared, and then I divide this by 8x squared. I get 2x left over here, and then I get plus 1 left over there. Because when I take 8x squared out of itself, I have to be left with 1. Then in the second one, if you look back up at step, let's see, where is this? Oh, step 2, where it says if the first number in the parentheses is negative, be sure to also factor out a negative. So that's the case here in A. I have to factor out a negative because that 6 is negative. I can also factor out a 3. I'll factor out a negative 3. So I'm dividing this by negative 3 and this by negative 3. I am left with a positive 2x plus 1. And hey, look, I did that correctly because 2x plus 1 and 2x plus 1 are the exact same thing. All right, so now I'm just going to bring my things together like I normally do, bring my factors together to create this two sets of parentheses. I have 8x squared minus 3, and then 2x plus 1. This should be a very familiar process to you. Taking out GCFs from both the groups, and then we're bringing these together here, and then bringing these together to form that factor. Now that I'm to this point, I can go ahead and set those both equal to 0 and solve for x. So 8x squared minus 3 equals 0. I'm going to add 3. Divide by 8. A couple steps here. And then don't forget, if I'm looking for x, but I have x squared, I have to take the square root of both sides. So I'm left with x, the plus or minus version of 3 over 8. And I cannot simplify root 3 over 8. It's just a fraction. I'm just going to leave it the way it is. But don't forget I have to add that plus or minus when I'm taking the square root of something. That's very important. I'll also solve for this one. So x plus 1 equals 0. I subtract 1 over. I divide by 2. And I get x equals negative 1/2. That one was a little more easy. Okay, so you should have been thinking in your head, hey, I actually do know how to do this process. The only thing different was I factored out that x squared in the beginning instead of just an x, so I ended up having to take the plus or minus version of an answer at the very end. Let's look at B. Looking at the first two terms and looking at the second two terms separately. From the first two, I can factor out 7x squared. And I'm left with x plus 4. From the second two, I can factor out a 5, and I'm left with x plus 4. Hey, look, I did that correctly. X plus 4 and x plus 4 are the same thing. So I can bring these down, just like I know how to do, into two separate factors. So I'm going to have 7x squared plus 5, and then x plus 4. Now I can just set those both equal to 0 and solve. So 7x squared plus 5 equals 0. Subtract over 5. I get 7x squared equals negative 5. Divided by 7. I get x squared equals negative 5 over 7. You might be thinking here, what do I do when I take the square root of a negative number? Well, if you recall from our quadratics unit, the square root of a negative 1 is I. So on the left I get x, but on the right side I'm actually going to break this up first. I get the square root of negative 1 times the square root of 5 over 7. And I also have that plus or minus out front. The square root of negative 1 is just going to turn into I. So my actual answer here is plus or minus I root 5 over 7. Now, if you want to skip this step right here and just write that when you take that negative out of the square root, it becomes I, that's totally fine too, because we already know that. That should be information that is already in our brain from Unit 4, which was from last semester. I'm going to finish this by setting the other thing equal to 0 as well, the x plus 4. So I'll subtract 4 from both sides, and I'll get x equals negative 4 as my answer. So here are my two answers for that one. Not too bad. The process is very familiar. The only thing we're adding is that we're working with cubics, or degrees of 3, instead of degrees of 2 that we're used to. Let's move on to the second page. Target 7, I can factor and solve a quartic in quadratic form. So this process is going to look very familiar as well, in the sense that we're actually going to be using just the factoring methods that we know. So when a is 1, when a is not 1, factoring out GCFs, and then maybe difference of squares here and there. But the thing is, we're starting with x to the 4th power. Okay, we're actually starting with that instead of x squared. So our factors are going to look slightly different here. So it says when factoring a quartic in quadratic form, it is the same process as factoring any quadratic. This time, however, each of the factors will start with an x squared. And what they mean by that is at the very end, when we get down to something that looks like this, instead of having x and x, we're going to have x squared and x squared. That's it. That's the only difference. There may also be a need to further simplification, or there may also need to be further simplification to check for. And we'll talk about that. Let's look at a. So it's in quadratic form. I have my x to the 4th minus 9x squared plus 18. So because my a value is 1, I'm just going to go ahead and think what times what is going to give me 18, and then what plus what will give me negative 9. Well, let's think about this. Factors of 18. I have 18 and 1, 9 and 2, 6 and 3. Ooh, 6 and 3 would work. It's supposed to be a positive 18 when I multiply, and I need a negative 9 when I add. So I'm going to do negative 6 and negative 3 here. Alright, and then I can pretty much skip this part because my a value was 1. Now, don't forget what I said. X squared here and x squared here. Minus 6 minus 3. So now I can just solve. I'm to that point now. X squared minus 6 equals 0. I add 6 to both sides. I get x squared equals 6. And then when I take the square root of both sides, I'm left with plus or minus the square root of 6. And that's it. Don't forget the plus or minus. X squared minus 3 equals 0. I'm going to add 3 to both sides. I get x squared equals 3. And then I take the square root of both sides. X equals plus or minus the square root of 3. And you cannot simplify root 3 or root 6, so we're just going to leave those the way they are. Simple enough. B. I'm going to start by factoring out a GCF because my leading term is not 1. Sometimes you can't factor a GCF out when your leading term is not 1. But in this case, since all the numbers are even, I'm just going to take a 2 out to start. I'm left with x to the 4th plus 2x squared minus 35. Alright, so now my a value is 1, which is kind of nice. I'm going to think, though, what times what will give me negative 35, and what plus what will give me positive 2. So over here, I'm going to write the factors of 35. I have 35 and 1, 5 and 7, and that's pretty much it. 5 and 7, the difference between those is 2, which is going to work, but I need a positive 2 So I'm going to do 7 minus 5. So 7 minus 5, and then 7 times a negative 5 will give me negative 35. So just like in A, I can skip to that part with the 2 sets of parentheses, but I cannot forget about that 2 out front. I also can't forget to put x squared here, because I'm working with x to the 4th. So I'm going to do plus 7 and minus 5, just like I said. At this point, we can solve. X squared plus 7 equals 0. When I subtract 7 from both sides, I get x squared equals negative 7. Taking the square root to get x by itself completely, I will get x equals plus or minus I root 7. Because I do have a negative sign under the square root there, so I have to remember to pull out the I. Now, going back really quick, it doesn't make sense for me to set 2 equal to 0. Because is 2 equal to 0? No, that doesn't work. So this is not one of my factors. If you end up doing that, you might catch yourself and say, well, 2 actually doesn't equal 0, so that can't be one of my answers. But if you had an x out front, then you could set x equal to 0. But in this case, 2 does not equal 0, so you're not going to set that equal to 0 and give me that as an answer. And then finally, x squared minus 5 equals 0. I add 5 to both sides. I get x squared equals 5, and then I take the square root of both sides. X equals plus or minus the square root of 5. There was no negative under the square root here, so I didn't have to take the I out, which is kind of nice. Alright, let's look at C, and then we'll look at D, and then we'll be done. Alright, so for C, 6m to the 4th minus 6m squared minus 72 equals 0. I can actually factor out a 6 here, which is going to be really nice. I'm left with m to the 4th minus m squared minus 12 equals 0. 6 goes into 72 12 times. Now my a value is 1 again, which is super nice. What times what will give me negative 12, and then what plus what will give me negative 1, which is my b value. Well, how many factors of 12 up here? Let's look. I have 12 and 1, 6 and 2, 3 and 4. 3 and 4 has a difference of 1. And if I do 3 minus 4, I will get negative 1. So 3 and negative 4. So now I can keep my 6 out front, but skip to that step with the 2 parentheses. Don't forget I have my m squared, not just m. It's going to be very important. Plus 3 minus 4. Now, I'm not going to go ahead and solve from here, because I should point out and recognize that m squared minus 4 is actually difference of squares. So, if you didn't recognize it, you went through and solved it, you would get points for the solving, but you wouldn't get full credit because you didn't recognize that you needed to keep factoring here. M squared minus 4 can be factored a little bit farther with difference of squares. We turn that into m plus 2, m minus 2. Now out front I still have my 6, I still have my m squared plus 3, but that m squared minus 4 had to be factored a little bit further in order to get full credit. Now I can go ahead and solve. M squared plus 3 equals 0. I subtract 3 from both sides. I get m squared equals negative 3. Taking the square root of both sides, I get m equals plus or minus I root 3. Don't forget the I, don't forget the plus or minus. I'm only taking the I out because I had a negative under the square root. M plus 2 equals 0. I subtract 2 from both sides. I get m equals negative 2. And then m minus 2 equals 0. I add 2 to both sides. And then I'm done. I'm finally finished. Let's look at D now, the last one. X to the 4th minus 1. It looks kind of like something we're used to. It kind of looks like difference of squares. Well, actually it is difference of squares. X to the 4th is a perfect square. Its square root is x squared. So this is a perfect square, that's a perfect square, and I have a minus sign in the middle. So this right off the bat is going to be difference of squares. the square root of x to the fourth is x squared, and then the square root of 1 is just 1. So my two factors here would be x squared plus 1, x squared minus 1. I am not done. Actually, I need to recognize this is difference of squares again. X squared minus 1. That will turn into x plus 1, x minus 1. So I still have my x squared plus 1, but x squared minus 1 will turn into 2 more sets of parentheses. X plus 1, x minus 1. Now I'm finally finished. Until you get to this point, if you ever see two perfect squares with a minus sign in the middle, you have to recognize that that is difference of squares, and you have to factor further. Now I can solve. X squared plus 1 equals 0. I subtract 1. I get x squared equals negative 1. When I take the square root, I do have to add that I and the plus or minus. So x equals plus or minus I root 1. Now, the square root of 1 is just 1, so you can actually leave this as plus or minus I. X plus 1 equals 0, and then x minus 1 equals 0. I get x equals negative 1, and then I'll get x equals positive 1 on this side. Phew, that's probably the most factoring you'll see in any of these. Difference of squares twice. But those are my three answers for that one. And that is all the notes we have for targets 6 and 7. If you have any questions, don't hesitate to ask one of your teachers or any of the Algebra 2 teachers. And yeah.